G'day, Dave here. Um, I thought I would um, give a brief demonstration of the occult Fresnel diffraction analysis that's been recently built into the software. And I thought this is a very good example to start with. Here we have two observers, Oksaki and Liu, have observed a chord each across this asteroid Cantor. The Oksaki, I hope I'm pronouncing that correctly, chord is central, and the predicted drop is 100%, or 9.3 magnitudes, or 100%. And sure enough, the light curve is to the limiting mag of the recording. So that's what's expected. However, this light curve by Liu, or Liu, is only to the 50% or slightly deeper level. What's happening here? And you can see that the chord passes near the southern limb of the asteroid, ellipsed shape. Is this Fresnel an effect? That is the shallow drop. Is that due to Fresnel? So let's have a look. First off, you need the two light curves in the light curve viewer, and that'll open automatically when you dive into the Fresnel tool. To get into the Fresnel tool, you go to Solutions and you click Open Fresnel Diffraction Tool. First window to open is the light curve viewer, and the program will input the limb plot that we've got down here into another window and display the shape that we've determined and the two chords, and it will pick one of the chords in the order that they've presented and automatically show the Fresnel plot. We're not particularly worried about the chord one. Chord one? Yeah, I guess so. We're more interested in the other ones at the moment. So we click the radio button over here, and we get this chord 2. The other thing to check, chord 2 has an image cadence of 80 milliseconds. So it seems to work best if we put about half the light curve cadence into the Fresnel tool. So we just increase that. So half of 80 milliseconds is, is 40 milliseconds. Seems to work best. Now, these two light curve, the DAT files, can be either retrieved from the data set that's uploaded. However, in this particular case, they haven't been uploaded yet, so I've got them locally in the folder. Where's occult? How do you? Right. Come on. where's my, it's down here on my other screen. In Occult, you load the two DAT files, if you're going to access them locally, into the light curve report folder, and there I have the two DAT files. So that gets access to them. And then you find the light curve viewer window. There it is there. To retrieve the light curve that's in the data set already, you need to take note of the number up here. So it'll be, 20,056 or something, or 10,428 or something, and you type that number in there. But because that's what it looks like without the Fresnel tool, because we're viewing them locally, we've got them down here. So we just simply click on the light curve, that file, and we select a Fresnel light curve. This will open up the Occult Fresnel folder, and we just, it's the 26th of the 5th, 14, so May 26, 5, there it is down there, right down the bottom. So there is the theoretical, the red line is the Fresnel curve you'd get with the chord going across in that particular position. Now here we have adjustment on the height. So we set that to about somewhere around there for the mid noise level of the full light. And we can now adjust the time resolution to right. So it's central. Now, as you can see, the chords in that particular location, the depth should have been a lot deeper than as was observed. However, if we drop the chords down or south 100 meters or 0.1 of a kilometer, we can have a look to see how that looks. And all you do now is you click the reread. It automatically generates the Fresnel, and just tell it to reread the curve, and it will put that into position, overlay it. So if that's not quite enough, so we're playing with meter resolutions, tens of meters resolutions here. So which gives you an idea how accurate this sort of stuff is. So reread. So here we have a match where we can move it a little bit to the right to match it. Not an absolute perfect match. We'd have to start playing around with shapes of the limb in this area here to get a perfect match, and we do that when we're playing around with satellite discoveries. But for this exercise, we have a very good match to confirm with a slight adjustment of minus 200 meters. We've determined that chord 2 was due to the shallowness of chord 2 was due to the Fresnel diffraction at the graze. And what I normally do here is I I just take a screenshot of this and put it in the file, so to prevent anybody have to add comments. And I would say something like here, or in this, I would say something like observed drop. APROX 60%. U2 Fresnel diffraction. Fresnel, one L, forget now. Okay, so that will confirm our findings. Save and give you an indication of the sensitivity of the Fresnel analysis. So I hope that's helpful. So without further ado, I'll sign off. So I'll stop the recording. How do you do that? Stop share and more, turn off recording. Bye for now. Dave out.